And C.
I didn't get an action.
Action.
Different. Blah, 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 blah. Okay, I'm just gonna start over.
Wait, okay, that's okay. We'll just cut it
Matters
to
for
whatever.
video editing.
We'll just cut it whatever.
We were tasked with creating a ceiling-mounted scissor jack, specifically to lift heavy machinery in a machine shop. So we were given some design requirements. We knew it had to lift 2,000 pounds, at least 6 inches, but some of them we had to choose. For example, we had certain failure modes we were looking at to make sure that it would work, and one of them was buckling. And we decided specifically to have a larger minimum factor of safety for buckling because we knew that it doesn't often have signs before it just catastrophically breaks. Once we settled in on these requirements, we put them into a model. And first we just sketched it out, we just wrote in what we wanted, input, output. Then we plugged it into Excel, and we learned that we needed to iterate between these because it was confusing at first what should be an output, what should be an input. After a few iterations, we settled in on a model that worked well, and that could help us compare designs.
So once we decided what our inputs and our outputs should be for our model, we then used the techniques we learned in this class to create an Excel model that would do all the calculations for us and that would allow us to iterate through several values. And so here you can see that model with our inputs and our outputs. Now we were a little bit concerned about whether or not this Excel model was accurate, and so we had someone in our group who hadn't worked on the Excel model independently do hand calculations to make sure that our numbers agreed with each other. And then we did further validation by testing out different values and looking at how it changed the design requirements and outputs of the model. From there, we were able to use our Excel model to optimize our design. To do this, we placed several constraints on the outputs, namely with our safety factors and our max displacement. And then we also had to put geometric constraints on our inputs. It was a little bit tricky to come up with everything the first time. For example, the first iteration wanted a diameter of the crossbar that was bigger than would fit with the geometries that we were specifying for the diagonals. But we iterated through several of these until we got a solution that was reasonable. And then we rounded these values up to nominal values to make sure that our final design would be cheap and doable.
Once we had optimized our model and figured out the dimensions we wanted, we put it into SolidWorks as shown here and made sure that the geometry worked. We then picked a part that we wouldn't be able to model by hand as well, which in our case was this part where the crossbar screws into the jack, and we decided to model that in FEA. At first, we found that we were getting much more stress than we anticipated, and we realized that there was a stress concentration right here in this area, and so by adding a fillet, we were able to cut the maximum stress by more than half. It was a very practical example of why we use FEA, and it's to find those stress concentrations before they become a problem. ANSYS is a very capable tool of modeling things that you can't really model by hand. It catches stress concentrations and different stresses that you wouldn't be able to tell just by looking at it.
So now we've explained our design process to you. There's a couple things we really want to highlight. Some have said that design is the interplay between creation and evaluation. And if we had to fit models in there, it would be right in the middle. So you create something, but you need to evaluate whether it was any good. And that's what models are for. In this case, we started with some simple hand calculations. We used those to verify that we were doing things correctly. We switched into Excel, slightly harder, better computationally. And then we used Excel to validate. And we slowly built up until we used everything from hand calculations through FEA to validate our design. Now from here, we as engineers take this knowledge we've gained and make our design decisions. The model can't do that for us, it can only inform our decisions. So in this case, we're going to select among multiple materials and multiple possibilities what sizes we're going to make, what stock, and how we're going to put everything together from there. Thanks for watching.